A piecewise function is a special type of function. It's like multiple functions being graphed on the same coordinate plane with different domains. Basically, it's like a bunch of different parts of lines being graphed together. So here's an example of a piecewise function. There's another type we're going to talk about in a minute, but for right now, this is a type of piecewise function. There are actually two equations, and the two equations are y equals 2x and y equals 8. It's just that each of those equations, when we graph it, we're going to graph it for only a set number of x values. That's your domain. So let's start with the first equation, y equals 2x. Well, the graph of y equals 2x has a y-intercept of 0, it has a slope of 2, so I'm going to go up to the right one, up to the right one, up to the right one. I can go the other way, down to the left one, down to the left one. I'm going to wait a second before I actually draw the line, but the line would go through those points. But now I'm going to tell you that I'm going to restrict it from 0 to 4. That means I'm going to restrict it from here at x equals 0 to here at x equals 4. And any other points that don't lie in that domain disappear. The other thing that I'm going to look at is I'm going to look at the inequality symbols, because if you recall, when you graph inequalities on a number line, sometimes we have these things called open circles, sometimes we have closed circles. Well, the little inequality symbols with a line underneath were closed circles. So I've got closed circles on each end of this graph. So it turns out that this is just a segment of the line that we would normally draw, because that piece only goes from x equals 0 to x equals 4. And now we're going to draw the other line on this graph. We're going to graph y equals 8. I'll graph it in a different color. Y equals 8 is actually a horizontal line. It's this line. Except that I'm not drawing the whole thing. I am starting at 4, and then I'm going to go to 7, and that's the only part I'm going to draw. Now, a minute ago, I just talked about open and closed circles, so you may be looking at this going, well, that should be an open circle. Well, the reason it's not in this case is because it's already on top of this blue dot. So we're going to leave it as a closed circle. So this is my piecewise graph. Notice there are no arrows. There can be arrows. If instead I had said that y is equal to 8 if x is greater than 4, then instead we would have drawn this. So there would have been an arrow. But in this case, there wasn't, so we're not going to worry about it. We have segments. Let's look at a very special type of piecewise function. We talked last year about something called absolute value graphs. And maybe you remember that absolute value graphs were V's. So you graph it on your coordinate plane and it would look like this. Well, it turns out that an absolute value function is really just a piecewise function. Let me get rid of this. It's the piecewise function f of x is equal to the graph of x when x is greater than 0, and f of x is equal to negative x when x is less than or equal to 0. All right, so I just put up a graph. Let's start with the first graph, which is y equals x. Well, the graph of y equals x is the line that goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4. And that way forever and ever. I'll make a nicer line here. There we go. However, in this piecewise function, we restricted this red graph to where x is greater than 0. Well, remember I said greater than if you graphed it on a number line is an open circle. So what I'm going to do is I'm going to get rid of this part of the graph. And there's an open circle here. And then the rest of the graph goes in the positive x direction. So you'll see the graph when x equals 1, when x equals 2, when x equals 3, when x equals 4, because that's where the x values are greater than 0. The second part of the graph, which is the graph of y equals negative x. Well, if you make a table of values and you graph it, or if you use a graphing calculator, you'll see that this graph goes through 0, 0 as well, and it goes through 1, negative 1, 2, negative 2, 3, negative 3. It goes through negative 1, 1, negative 2, 2, negative 3, 3, and so y equals negative x is this graph. Except that we're restricting this part of the graph to the values where x is less than or equal to 0. That means that this line actually starts at 0. Let me get rid of some of these dots here. It starts here at 0 with a closed circle, and it goes in the negative x direction, and this is where the graph was. And that's where your v comes from. So a absolute value graph is really just a piecewise function. It's the piecewise function f of x is equal to x when x is greater than 0, and it's f of x equals negative x when x is less than or equal to 0. The graphing calculator will graph piecewise functions for you, but you have to learn how to type it in correctly. So, what we're going to do when we graph piecewise functions is we're going to graph each function independently. So it doesn't matter if there are 2 functions or 3 functions. In your y1 equals, you would put in x, and for y2 equals, you would put x squared. But we have to tell the calculator that there's a restriction on the domain. Here's how it works. You're going to use the division symbol. The calculator will understand that you're not dividing and that you're putting in some additional information. Then you're going to use an open parentheses. Now, here's the deal. Compound functions, you actually have to rewrite them. A compound function, or sorry, not compound function, but compound inequality. A compound inequality was 2 inequalities that are kind of smushed together. Well, there really are 2 inequalities going on here. This is one of them. That inequality is negative 2 is less than x. So you can type in negative 2, and then here's where you find the less than symbol. Press second math. This is called the test function. So when you do second math, all of a sudden you'll get a list of inequality symbols. Pick less than, and then put in x. Now, a compound inequality was an and statement. Remember and or statements? Or statements will always have the word or between the 2 inequalities. But an and statement can be written in one of 2 ways. It can either be written like it is in this problem, or it can be written like this. And unfortunately, because of the restriction on the calculator will not understand a compound inequality unless you actually put the word and between them. How do I write in the word and? Well, I know you're looking at your calculator going, oh, well, there are little letters, I'll type it in. No, 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 no. You're going to go back to second math. And I want you to notice that if you arrow one to the right, you'll see the word logic. And if you put the cursor on logic, you will find and, or, probably nor. We don't need that one. We just need and. So click on and so that and pops up. And then type in x less than or equal to 2. You're going to have to go back to this test function to put in the less than or equal to symbol. You need to do it again for the second function. The second function in this case was x squared. So you'll put in division sign, open parentheses, x. You need to go to second math to put in greater than, and then 2, and then close it. And this is what my calculator screen looks like. The cursor stopped here, so there's actually an x right there. And then there's more stuff over here that you can't see. It's the x's less than or equal to 2. So now when you hit graph, you'll see this. Well, here is your linear function, y equals x, but it's only graphed from 2 to negative 2. Let me go back here. And then this is the graph of y equals x squared, starting at x is 2. And then when x is 3, it's 9. And then when x is 4, it's 16. So it's up here so you can't see it. This is a piecewise function. Graphing more than one function on the same coordinate plane, but they have restrictions to their domain. Now, something I want to mention real quick. Sometimes piecewise functions connect, and sometimes they don't connect. We're going to call this a gap in the graph. Keep that in the back of your head because that's going to come back later in the school year.